event loop. So let's execute our first bit of code. It's this console.log, which is just going to log out first. So we push it into the stack. And you can think of the stack as being a bit like an array-like object where things can be pushed onto it and popped off the top of it. In the stack, our code gets executed. We log out first. The stack can be cleared and our first task is done. And just to be clear, this is a simplification. If we had more complex code with functions doing lots of tasks or calling other functions, the call stack would be busier, but let's keep it simple. Okay, next we come to the set timeout. So now we need to work asynchronously. The code goes into the stack, and here things get interesting. The stack passes set timeouts function to a web API, and there it gets a timer which is going to count the 5,000 milliseconds. Now the stack can pop that task off, and we move on to the next line of code, which is the third console.log. We pass it over to the stack. It executes, so we log out third, and then the stack gets cleared, and that line of code is done. Back at the web API, the timer counts the milliseconds, and then it's done. So it passes the function down to the task queue. The function is the only code in the task queue, so it's at the front of the queue. And here comes the event loop. Its job is to keep an eye on the task queue and the stack, and when the stack is empty, it will grab the task from the top of the task queue and push it to the stack. And there it executes. So we log out second, the stack empties, and we're done. And we can see the order of execution first, third, and second. Right, let's pause here a moment because there are a few complexities I think we should deal with. Firstly, what are web APIs? Well, web APIs are provided by the browser, they're not part of the JavaScript language, and they have functionality for things like DOM manipulation, data requests, timers like set timeout and set interval as we've seen, and plenty of other things besides. So in the case of our set timeout, the relevant web API can hold our code, count the milliseconds until its time is up, and then pass it to the task queue. And as the web APIs are not part of JavaScript, while you interact with them all the time, you never actually work with them directly. So really, it's just a good idea to know that they're there and to know what they're doing. You don't need to take a deeper dive into it than that. Now, things don't always go as smoothly as in our first example. Imagine this is our code base. I've got a console.log, a second console.log inside the set timeout, but down here I'm calling a super heavy function, which is mining Bitcoin. So we go through the process. We send the first item to the call stack, it gets executed and logged out. Then we come onto the set timeout, it goes to the call stack. We know the function gets passed to the web API, the timer starts, we clear the stack, and that brings us on to the function where we're mining Bitcoin. Let's pass that into the call stack. Okay, that function is going to take a long time. So back at the web APIs, the timer finishes and the function is passed down to the task queue. But the event loop, which is keeping an eye on the call stack and the task queue, recognizes that this function has not yet completed. And so we wait, and eventually the mine Bitcoin function does complete. We're logging out some binary here, which is not really what Bitcoin code looks like. But now the call stack can be emptied, that function has completed, and the event loop can do its thing and pass our second console.log into the call stack where it gets executed. And the call stack, of course, empties. And in this next example, things are even worse. We're at the stage where mine Bitcoin is in the call stack, that's being executed at the moment. The function from our set timeout is with the web API. We've got this timer. Let's see what's about to happen to the timer. The time completes, so the web API passes the function to the task queue. But look, it's not alone in the task queue. It's got two tasks ahead of it, tasks A and B, which could be a couple of functions, for example. So now this function has to wait for mine Bitcoin to complete so that the stack can be emptied, and then it's also going to have to wait for task A and task B to complete through the call stack before it will get called. So it's being significantly delayed. And that, by the way, is a good thing. It's what we want to happen. If this code here was just shoved into the call stack as soon as the 5,000 milliseconds had elapsed, it would get mixed up with any other code that was already in there, and that would cause chaos. And so although we only specified a delay of 5,000 milliseconds, we have to be prepared for the fact that it can take longer. And we can actually prove that with some code. Here, I've got performance.now, and that is a really neat tool which returns what they call a high-resolution timestamp in milliseconds. Basically, it's a really accurate timestamp. I'm using it again right here inside this set timeout. We've got a delay of just 1,000 milliseconds. And what we're doing here then is we're subtracting the start time from the end time, and that will give us the time in milliseconds that it took our code to execute. Okay, I'm going to hit save and run the code. And if we open up the console, we've got 1000.89 milliseconds, so it took a little bit more than a millisecond. Let's just grab that, and I'm just going to save it right here. Now I'm going to uncomment this code. It's a for loop. It's going to do these completely pointless calculations 1 million times. I'm not going to log anything out because obviously I don't want to be scrolling through all of that. It will take hours, but we can imagine now what is happening. We're going to have our set timeout over here with the web API while it counts down its 1000 milliseconds, but in the call stack, we're going to have a million calculations going on. So we should see a delay while the code from the set timeout waits in the task queue. Let's hit save and see what we get. And if I open up the console, we're getting 1001.5 milliseconds. So although the difference between them is pretty small, we can see that this one, where we ran all of these calculations, took significantly longer. So in a way, that's just testament to how fast JavaScript is, but also it allows us to answer our original question. How long will it be before this code executes? Well, a minimum of 5,000 milliseconds, but it could be more depending what's in the task queue and the call stack. And if we really were mining Bitcoin, then this code right here wouldn't execute until Christmas next year. Okay, hopefully that has given you a bit more of an understanding on how JavaScript is working with the browser. When you're ready, let's move on.